Look at problem number 1. First of all, can you do that?
Yes.
Oh yeah.
Yes, bless you. Problem number 1, you can do it.
Mm-hmm.
Now, before we move too far into this, there's an exception to what we talked about yesterday in the instructions. Instructions say to find the product or quotient, so we're either going to be doing multiplication or division. But it tells you you're going to give only the positive root. So the root is the answer to this, and you're only going to give the positive one. So you don't need to write that plus or minus that we were doing in yesterday's lesson.
Okay.
On this page. So just as soon as you were shown the rule or reminded of it, they take it away from you. Okay? What'd you get for number 1?
24.
For which
Everyone
one?
agree with that?
Yes. Number 1 is 24.
Oh,
What you would write on the blank to ensure that you're demonstrating it properly is you would take the one problem, the square root of 64, and you would, alright, so this is the problem as it's set up. But you would write 64 times 9 underneath the radical, do that, find out what that answer is, and then take the square root of that answer. Number 2, can you do that one?
7 over 3.
Yes.
So the answer is yes, and you have an answer. Now can you simplify 7 over 3 at all?
No.
Well, you can turn it into a mixed number. What would the mixed number be?
It would be 2 and 1/3.
2 and 1/3. So, okay. Can you do number 3?
Yes. You can do all these, I think.
All but no all. There's one.
Oh, okay, so I can stop asking that question.
Please do.
Yes.
Well, just making sure you're looking. Maybe they threw a curveball in there that, whoa.
But can you
Can't
do
do
all
that.
of them on your thing?
Yes.
Really?
So
I would suggest you use your calculator to get the answer, but you need to show that intermediary step when you combine the two separates into one thing. Or if it's a division one, maybe you need to separate it out or what have you, depending on what problem that you're given.
I think just the answer for
So what would you do then for number 4? Number 4 is quite something else. You've got a 4 there, a 16 here, and where is that 3? Is it supposed to be living out here? All over the square root of 4?
I believe so.
So what's a good way to simplify that?
plug it into your calculator.
Well, what's the 4th root of 16? So it's not a
2.
square root or a cube root. 4th root is
2.
2. So you write 2 square root of 3 over 2, because that's just 2. Then you simplify that down to your final answer, which was what? What's this simplify out to and give you as a result?
On number 4.
4. Good. Number 5, you really need to use the table, so that way you're making sure your answer matches. So you'll pull out your table from the back, and what do you get?
Can we pull it out of the page?
No, it needs to be in the back. You just flip back and read it.
7.416.
Now, how did you find that? Well, you were looking for this, which is that. So you go back to your table, find 55, scroll across, and you see 7.416. Number 10. This is a cube root problem. We're jumping down to number 10 because 6 through 9 are very similar. So cube root in number 10 is what?
5 at the top. And then
Because you're
3.
You're separating out the giant cube root problem, because can you divide 125 by 27? No. So you need to separate it out, and then you get the cube root of 125 over the cube root of 27. Can you do those individually?
Yes.
Those have cubes, so that makes it super easy. You find on the top, cube root of 125 is 5. Cube root of 27 is
3.
3. So you have 5 over 3. 5 over 3 can be simplified or turned into a mixed number of what value?
1 and 2/3.
1 and 2/3. So that's how that one works out. So 11 is very similar as we did for number 4. So looking down at 13 then. Square root of 2 times the square root of 51. What do you get there?
Which one? Which number?
13?
It would be 10.100.
Now if we look at my table,
Just times it
I
together.
don't have 1 and 2 in there.
Well, all I did was get the 51
You
and then
do.
times it by the 2.
Yeah.
So that's what you'll need to do. If the number underneath the square root is larger, then just do it that way.
So 10.10. I mean 10.010.
10 point, what is it?
010.
0, right?
Say it again.
Is this what you got?
Yeah.
And you need to have 3 decimal places.
What times 3 equals x?
You could write it like this.
What's the square root of x?
This is what times 3 equals x. You have 2 variables in your what you're asking me, so you can't solve that.
Well, why is
Actually, there is one thing that would equal that.
x?
X over 3.
Oh, that's how you do it. Okay, thank you.
That would equal x. How about that? I don't remember stump the teacher being on the agenda, but you can't.
Yeah, you can. What's the meaning of life?
Alright, number.
Stumped.
The meaning of life is whatever God determines. Number 14 is like the others we've done. It's like 7 and the others, 9 and 2. They're all very similar. So number 15, we're going to tackle that one just because it's a 5th root. 5th root. Say it with me. So, how do you handle that one?
It's just giving you a number.
This is the problem. How do you do it?
Oh, answer the next one.
Like we've done on the others, right? You want to split this into 2. And what do you get at the top?
It's just 1/2.
Well, anything square root, cube root, 5th root, whatever of 1 is what? 1. Then you're just dealing with the 5th root of 32 on the bottom. What's the question?
I have a question.
What's the 5th root of 32?
2.
Oh,
1/2.
you would find that that's 2. And then 2 on the bottom gives you 1/2. Number 16. Uh-oh.
Easy. Divide them both by 2.
There's no numbers. It's x to the 4 over y to the 8, and it's the square root of that. Well, we know how to do this. What's the square root of x to the 4th? That's x squared. What's the square root of y to the 8? What is that again? Square root of y to the 8?
4.
That's y to the 4.
Oh, there you go. Easy.
Now, can I cancel these? Can I cancel the 2 and the 4? Why not?
Just because I don't see a square.
Well, the bases are not similar, so I can't do anything with that.
No similar denominators.
If it was that, can I do something with that?
Yes.
Square root of x to the 4th? What would that be?
1 over x squared.
Yeah, it would. If this, which does not match this anymore, was my problem, then I would just have 1 over x squared in the bottom.
Yep.
What's another way I could write that?
X to the negative 2.
X to the negative 2. Good. That's another way I can write that problem. 17. You have a cube root of 8 over 64. So like before, we're going to split that into 2. Cube root of 8, cube root of 64.
Just 1/2.
This gives you what?
1/2.
Cube root of 8 is 1/2.
No, it's 2.
What's a cube root of 8?
2.
2.
Cube root of 64 is 4.
That's 4, and that does simplify down to 1/2 at the end. Okay? Now look at the next page. What are we doing there? Page 11.
Something really hard.
Well, we just did multiplication and division practice with radicals. Now it feels like we're backing up to see how we can do subtraction or adding. Okay, well, adding and subtracting. Do you think it's going to be the same or different? Can you add radicals together? Well, what can be combined and what cannot be combined depends upon what, depends on some factors. So you're looking at those examples there on page 13, page 11. See the top? So it cannot be combined. Look there in the middle. You have the cube root of 5 plus the cube root of 4. Those cannot be combined because different radicands. What's the radicand again? That's the number under the square root symbol.
Yep.
Then there's the fourth root of 7 plus square root of 7. Those can't be combined because they're different roots. They have the same radicand, but different roots. So it looks like in order to combine these radicals, we need to have the same thing in the n and the same thing in the x. Yep. That's the only way to actually do it.
Looks like
Well,
it.
then you could combine it. An example of that is given to you there. You've got the cube root of 5 plus the cube root of 5. In fact, the n's are the same and the x's are the same, so I combine that to just get what? 2 of the cube root of 5. I have 2 of those. So 2 times that. It's the same with subtraction. Cannot be combined if they're different radicands or the roots are different. And if it's a whole list, if you have a whole list of things, same thing, same rules apply. So your remember box tells you, in order to add or subtract radical expressions, roots and radicands must be the same. I think we got it. So, in order to add or subtract radical expressions, the roots and the radicands must be the
Same.
Oh, with more enthusiasm. The roots and the radicands must be the
Same.
Oh, we gotta get the same word all at the same time. I think we can do it. Third try. The roots and the radicands must be the
Congruent.
Same.
Alright.
Make congruent better.
So then we are practicing that. Find the sum or difference of the given terms. If they cannot be combined because the roots and the radicands are not the same, then you would just write they cannot be combined. Or C, B, C. And you need to give the reason. Look at number 2. You have square root of 10 minus 3 square root of 11 plus square root of 10. So if you write cannot be combined in the blank, are you right or wrong?
Right.
You're wrong. Because you have the square root of 10 minus 3 square root of 11. Sure, it can't do anything there, but plus square root of 10. You have something you can combine. I didn't say you had to combine everything, but if you can combine anything, then don't write cannot be combined. What is the answer actually here? Well, you have 2 of those, so you have 2 square root of 10 minus 3 square root of 11. That is
Negative 3 square root of 11 plus 2 square root of 10. You did them all.
Which ones?
number 3.
All these?
Can you do anything with number 3?
Yes.
The answer is square root. It's not a number.
get for number 3? Well, so you have that square root of 17 at the end, 2 square root of 17 at the beginning, and in the middle you're subtracting cube root of 17.
Cannot be combined.
So you can't do anything with this, but you can combine the first term and the last term to get 3 square root of 17 minus cube root of 17. So that's what the answer is. So these are actually pretty simple, right? So let's look at number 5. Can you combine anything there?
Yes.
We have cube roots of 5s. And the middle term, though, doesn't combine with anything. But you have, what is your answer there, though, actually?
4 cube root of 5 plus 2.
Negative 2?
Yeah.
Negative 2.
Negative 2 cube root of 5 plus 2 square root of 5. Now,
Does it matter what order you put them in?
the answer order matters. We go with our descending powers, but you cannot have the first term as a negative. So you're going to end up with 2 cube root of 5 plus 2 square root of 5.
Negative 2.
You did. You did it right.
Oh, I thought you said negative can't be first.
So we need to bring this out front. Okay, so you just write a 2 square root of 5 minus 2 cube root of 5. You just switch the 2 around. Our properties of addition tell us that we can do that. We can combine these in any order. So just switch them around, that way my negative is in the middle. Number 7. Answer.
No, cannot be combined.
Absolutely
Why?
nothing.
Why can they not be combined if in fact that is the correct answer? They have different what?
Exponents.
Those are not exponents. Those are called roots.
They're exponents.
In terms of a radical, those are the roots, not exponents.
Like in Linux.
Number 8.
Cannot
What
be
do you do
combined.
there? Why?
Because
They have different roots. They have different roots again. Roots are different. Alright, we're continuing this on the next page, but we're only going to do one more in one group for now. Number 9.
Mm-hmm.
Can that be combined?
Absolutely.
What do you get for your result?
3 root 3 over 9. Take away 2 square root of 9 plus 5.
I don't
No, it's 4.
see any of that on here.
You said we're doing 9?
Yep.
Yeah, what I have is correct, so.
4 minus 2, the square root of 9 plus the cube root of 9.
Yeah.
Wow.
I flipped it around.
Simplify everything that can be simplified and perform whatever operations you can perform.
You can only do 1.
Always look for things like that. So this is 4 plus 3 minus 3 times 3 plus cube root of 9.
Why did you get rid of? Oh, I see. You got rid of the 9. That makes sense.
So this is
7,
7 minus
9.
9. So minus
negative
2 plus cube root of 9. In this case though, I'm going to leave this negative 2 out front because it doesn't have a radical with it. So it needs to be out front, and the radical stuff needs to be over this way.
Okay.
So you wouldn't actually switch these around in this case.
Gotcha.
Okay,
Wait, why?
this one is the least complex term, just a negative 2, needs to be out front. Any of the radicals would be behind it.
But I have for my 4 negative 2, the square root of 9 plus the cube root of 9.
Well, if you don't have this, it's not right. And the reason why is the step above it, how we got there. 4 plus 3 minus 3 times 3, which is 9. So this is 7
So-
minus 9 gives you negative 2.
So the 4 is combined with the numbers outside of the bracket.
No. You're simplifying. What's the square root of 9?
3.
3.
I gotcha. Okay.
So if they throw you a little tricky trick like that, they're expecting you maybe to not notice that.
Gotcha.
But that's okay. Those are things that you may not always notice right away. That's why you always gotta be looking. In math, you're looking. What can I do to simplify this even more? And in case you haven't got enough practice of simplifying radicals, the whole next section, the entire objective is just that. Simplify radicals. Now we're going to go the other way around. We're going to take a radical and try to break it down into its simplest parts. So you see there in the example, they have a square root of 54. So what do you do with that? Not looking to look up our table and find the square root of 54, but we're looking to see, is there something else I can do with this to simplify it first? Well, think about in terms of factors. That's what we want to start thinking immediately. What are the factors of 54? Well, there's 6 and 9. I'm going to choose those as factors because one of those is already square rootable, right? Which one is that? 9. The 9 is square rootable. We just saw that in the last problem we did. Square root of 9 is 3. So if I'm going to break square root of 54 into some parts, because of what we learned earlier, I know that I can write 6 times 9 underneath here. And that is the same as square root of 6 times the square root of 9. This, I know, simplifies down to 3, so the 3 comes out front, and it's 3 square root of 6. So you bring any of your coefficient terms out to the front. You always write them in the front. You wouldn't write square root of 6 times 3. You wouldn't write it like that. The simple numbers always come out front, whether you're adding, subtracting, or multiplying. They're going to come out front. So you wouldn't write it like that, you would write it like this. That makes sense?
Yes, sir.
This would work if it was a cube root, fourth root, fifth root, whatever. You want to factor, break your number here, the large number, into some factors that are going to either be square rootable or cube rootable or whatever the case may be. Even if it's a big number like 32,400, you start breaking it down into smaller parts. As it shows you in the example, that's 4 times 81 times 100. To find that on your own is going to involve a lot of T&E, a little trial and error. You'll eventually get there.
Yay.
The same thing would apply if you had variables. Same rules apply. You know how to do that if it's a variable. The sums and differences of radicals may be simplified. So before you add something together, like we were just doing in the previous step, if it's a little complex, simplify it first. They caught us off guard with that one on number 9 when they gave us a square root of 9. But now you know, oh, I look for ways I can simplify the individual terms first before I look to add or subtract, right?
Yes, sir.
So that will always be a good rule to follow. Make sure that you review those steps on the bottom of page 12 underneath the objective. And then our final page for today is 13. So let's jump in on problem number 5. I really like problem number 5. It says 3 times square root of 27, or 3 square root of 27. You generally don't say times there. You would just say 3 square root of 27 minus, not take away, 48.
Why does the marker make the thing look like a mirror?
It's fun, right? Special marker.
It's like you're drawing a mirror.
Yeah. 3 square root of 27 minus square root of 48. Simplify first. What do we know about factors of 27?
9 and 3.
Why do I know that 9 and 3 are factors of 27?
Because they equal track.
Well, just because we have memorized that already. Do you remember factoring rules? If you add 2 and 7, you get 9. That makes 9 and 3 factors. Remember those way back in the day?
No.
I think you're way
Really?
back. Way back. Okay. So I would write this as 3, square root of, and then we know this is 9 times 3 minus. And then, so what are some factors of 48? Anything square rootable?
12 and 4.
16.
Or 16.
12 and 4.
So 4.
4 would be square rootable, then I'd be left with 12, which is another 4. Oh wait, 4 times 4, that's 16. So I can save myself a step if I choose 16 times, what is it?
3.
16 times 3 is 48.
You just put the 3 outside of both of them. Like 9 squared is 9, 3 squared is 16.
Well, say what?
Never mind, just keep on doing it.
So individually, this is the square root of 9 and the square root of 3. Square root of 16, square root of 3. Can I do anything with square root of 3? No, so that's going to be set aside for a moment. But square root of 16 by itself simplifies to 4, so I'll write that out front.
But 4 is also square root.
This is square root of 3 here, but square root of 9 is
3.
so I'll write that up front. There's already a 3 there, so I can combine those two to get, what, 9? So I have 9 square root of 3 minus 4 square root of 3. So really what I'm doing here is I'm subtracting the 9 and the 4 as if these are sort of like a variable. Is a good way to think about it. If that was like an x or a y and this was the same variable, I can combine them. Because remember, we just learned that rule earlier. If the root and the radicand are the same, we can combine them. In this case, the root and the radicand are the same, so they can be combined. So 9 minus 4 gives me 5, square root of 3, and we're going to be done. Number 8. Now we have variables in the radicand. That's pretty exciting. Can I combine anything?
Absolutely not.
Well, not yet, because it's kind of a mess, but I need to look for things I can simplify. And just like the last problem we did, I'm sure you're noticing all the numbers they're giving you are square rootable numbers. You see that? So I'm focusing on this square root of 9 separately. This is a whole term, but this is a square root of x, square root of 9, which is a 3. Square root of 9 simplifies to 3. Plus square root of 16, which is 4. The square root of x remains. Minus, and then square root of 25 is what? 5. And the square root of x remains. Now I have a root and a radicand that's the same, so I can combine these just as if these were like a variable. So 3 plus 4 minus 5 is
2.
2. 2 square root of x as my result. Any questions on that so far?
Nope.
Then let's jump down to number 11. Now we've got a bit more going on. It's good to practice these more complex ones because these are the ones, of course, you'll see in the future. So x square root of 98, that's something. Whew. Minus square root of 75x squared plus 3x square root of 7. Where am I at? 32. Okay, what do I do with the first one?
Absolutely.
Factors of 98, that's the first thing I gotta be thinking about. What are they?
10 times 9. No, wait, never mind. I got
10 times 9. Not 98.
12, no, 1.
It's 49. Put 49 times 2.
Start with the simplest thing. Think about 2 times what is 98? 49. Hey, 49, that's square rootable. So now I have x square root of 49 times 2. I know that square root of 49 is 7, so that becomes, I bring that 7 out in front of the x, because that's just how we do it. 7, coefficient goes out in the front, so that's the number. X, square root of 2. The x is already there. Now we're just carrying down what we've been working on. So square root is 75. Well, is there a square root of 75?
Nope.
No, but what's hiding there? What factor of
5
75 is
and
3? Well, 25. So 25 and 3. So square root of 25 times 3. And then also x squared is in that mix. So the 25, square root of 25 by itself is 5.
5x.
That one's done. Can I do anything with the x squared?
Yeah, you can make it
Well,
x.
square root of x squared is x. Can I do anything with the 3?
No.
So that remains. Plus. How about 32? Anything there?
2.
Factors of 32 is 2 and
3.
16.
Oh, yeah.
That was pretty handy. So plus 3x.
So 4.
And then underneath here I have 16 times 2. So I'm focused on the square root of 16 being 4. So here's what I have. I have 3x times 4 square root of 2. So what is this? How do I
12.
deal with that part right there? Well, that's just 12x, right? And then the square root of 2 would stay with it. That. Oh, are we done? Oh,
Yes.
Now we gotta.
oh, not done yet. Oh, I got this. Can I do anything with the square root of 3? No, I can't. But I have a square root of 2 and a square root of 2. And look, it even conveniently has a 12x and a 7x in front of it, so I can easily combine them. So 7x and 12x becomes 19x square root of 2 minus 5x square root of 3. Now can I combine that 19x that's left over with the 5x?
No, definitely not.
Oh, why not?
Because the radicands are the same.
Oh, so that's my answer then. Number 14. Look at that. A lot of variables in 14, a lot of them. It's a variable soup.
Easiest one I've seen all day.
So you start with square root of 9, that's 3. Then square root of a squared, that's a. This one is often very tricky for a lot of folks, so you gotta work your way through these carefully.
BC squared. Square root of BC.
So very carefully, we're looking at 9a squared bc. And we're dealing with each one of these by themselves. Square root of 9a, square root of that, square root of that. You can break these apart like this and focus on each one's square root. This I know is a 3, that is an a. This remains, and this remains. So I learned before that if by multiplying radicands, I just take them apart and multiply them together that way. So I don't need quite so much space, but that's what I'm left with. 3a square root of bc is what's left from that.
A.
Then I deal with the second part, square root of a squared bc.
The answer becoming ABC.
So I'm noticing that little trend is the same, it's in both. So that means I'm going to end up with an a out front, and the second one with square root of bc, so I can combine that at the end to get what?
2ABC.
I'll have 3a minus a, so that's going to give me 2a square root of bc.